Maybe we can start.
Yes. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to Bioprocess Engineering Week 2021 by Brawijaya. Greetings to the Honorable Professor Imam Santoso as the Dean of Culture Technology, Dr. Ahmad Adi Sulianto as the Head of Agriculture Engineering, Dr. Yusuf Wibisono as the Head of Bioprocess Engineering Study Program, also the Honorable Mehretie and the Honorable all lecturers in the Faculty of Agriculture Technology, and last but not least, Process Engineering Week. To begin our lecture today, I would like to introduce myself. My name is Keisha Milenia as the Master of Ceremony of Bioprocess Engineering International Guest Lecture, the 8th series of Bioprocess Engineering Week 2021 with theme Bioproduct Extraction and topic sample prepare headspace, solid phase, and supercritical fluid extractions. Dear honorable guests and participants, before we start our main event, let's start this event with a prayer first. So the event will be going well. The prayer starts. All right, the prayer's done. Okay, before we are going to our main event today, let me introduce you to the rundown of this event. We will start with the opening, then we will speech from the Dean of Faculty of Agricultural Technology, then we will have guest lecture with Dr. Solomon Mehretie as speaker, and Dr. Dimas Firmanda Alriza as moderator, then we will have question and answer session. Then we will have ice breaking, and the last one is closing and photo session. And also, I would like to remind all participants to pay attention to the rules. I will read the guest lecture general rule today. So first, when you are in Zoom meeting room, you are already using the name in the format, name_institution. And then during guest lecture, participants should turn off their mic and can turn it on only when the moderator has invited them to talk. Also, don't forget to turn on your camera. And the third one is questions could be asked via Zoom group chat or can be addressed directly to the moderator. And the last one is attendance form will be shared during the lecture. So for all participants, don't forget to fill in the attendance form that will be given in the room chat. So your attendance will be recorded by us for the certificate. All right, so let's begin our first agenda today. Let's hear the welcoming speech from Professor Imam Santoso. For Professor Imam Santoso, time is yours.
Thank you, MC. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon or good morning for Dr. Solomon Mehretie. Thank you for your time and would like to share your knowledge and experience related with our topic today. The Honorable, our speaker, Dr. Solomon Mehretie from Ethiopia, Head of Department of Agricultural Engineering, Dr. Ahmad Adi Sulianto, and Head of the Study Program of Bioprocess Engineering, Dr. Yusuf Wibisono, committees, and all participants. International guest lecture, like our agenda today, is one of our effort to increase number of international events so that it can contribute to increase the contribution in international reputation. So I am as a Dean of Faculty of Agricultural Technology, Universitas Brawijaya. Appreciate and very happy to open this ceremony, this international guest lecture, because in this event, it will be discussed about the special topic related with the bioprocess engineering. The namely is solid phase extraction of bioproducts. As we know, that solid phase extraction is one of the famous techniques used for fractionation, especially for antioxidant compounds. It is a simple and low-cost method as compared to other liquid extraction method, while it can reduce the use of solvents. Some research have shown that SVE, solid phase extraction, is the most suitable procedure for purifying the crab extract and improve the organoleptic capacity of the. So this is a very interesting topic, I think. As we know that Indonesia is a country which is blessed by biodiversity, maybe the second or the third biggest in the world. We have a lot and various bioproducts that could be harnessed and used for many purposes, of course. And I also noticed that Ethiopia have a lot of similarity, biodiversity also, like at least we are same as a tropical country, which may have similar bioproduct. So I think that this discussion will be fruitful for us and will be the beginning of our future collaboration, especially related with bioprocess engineering. Again, thank you for Dr. Solomon, who has allocated time and join and sharing knowledge with us, and all of the committee, of course, and all of the participants. Thank you very much. Please enjoy this event. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Imam Santoso, for the welcoming speech. Now let's move on to the next agenda. Now I would like to introduce you to the moderator for today's sessions. He is Dr. Dimas Firmanda Al-Riza, as a lecturer of Department of Agriculture Engineering in Universitas Brawijaya. So without further ado, please welcome Dr. Dimas Firmanda Al-Riza. Time is yours.
Okay, thank you very much, Kezia. Could you hear my voice?
Yes, it's very clear.
Okay. Okay, hello everyone. Thank you very much for Professor Dr. Imam Santoso for the welcoming speech. I'm Dimas. I will be your moderator today. Today we will have a discussion with Dr. Solomon. So before we start the lecture, I would like to introduce Dr. Solomon. Actually, he's my friend. We met in Japan during his postdoctoral course. He's from Addis Ababa University in Ethiopia. He's one of the best university in Ethiopia. He did his bachelor degree, master degree, and he got also PhD from Addis Ababa University. And he have also some international experience, such as postdoctoral fellowship in Kyoto University, research visit in Institute of Catalysis and Petroleum Chemistry in Madrid, Spain, and also research visit in Lund University, Sweden. And I discussed a lot during my time in Japan with Solomon, Dr. Solomon, and I think he could explain very complex thing in a simple way. So I'm very looking forward to his lecture. So please welcome Dr. Solomon. Time and place is yours. Hello, Dr. Solomon, maybe you can unmute your microphone.
Thank you.
Okay, we can hear you.
Thank you, all of you. for the nice introduction and the opening. I'm Solomon. So this is Addis Ababa University opening door. Very kind college also. The chemistry, before I go to the topic on the solid sample preparation of the different bioproducts using headspace, solid phase, and supercritical extraction, let me introduce where we are. I am in the Horn of Africa. As you can see here, Addis Ababa is here in the center. In fact, in the center also, the university there, and the oldest university in the country. If you look at the landscape of Ethiopia, you can find a terrain, different terrain like this, from 4,500 above sea level to 160 meters below sea level, Afar region. So it's a very wide climatic condition in Ethiopia you can find. But in Addis, it is in between. The temperature is quite comfortable. This is my department. This is a building of chemistry department. Here is my research lab. And my office is down in the, this is a of my department. In my department, there are 4 basic chemistry streams: analytical, inorganic, physical, and organic. The streams we are in, I am in the analytical stream. Now, when we go to the topic of my talk, the outline is just shown you in the picture, solid phase extraction, and then an extension of solid phase extraction, we have solid phase micro extraction, and finally we will discuss on supercritical fluid extraction. These are the basic part we are going to discuss. When you come to the solid phase extraction, the solid phase extraction is a method of sample preparation that concentrate and purify analyte from solution by a process, meaning you need to have a sorbent like this, and you load your sample. Then the sample has some impurities, you remove the impurities, and then finally you will elute the analyte of interest. Other way of describing solid phase extraction is just a simple cleanup mechanism where interferences are retained and analyte can pass through. So traditionally, what you do in sample preparation, the commonly we know is that simple liquid-liquid extraction. How you do liquid-liquid extraction? Just by using a separatory funnel. And you apply 2 solvents. One is polar, the other is non-polar. And this mixture, your analyte is in the aqueous medium, and your another substance you want to extract is in non-aqueous medium, usually non-polar solvent. So it is like oil and water. So there is a phase separation. Then you shake it thoroughly. You shake it thoroughly, and finally the analyte of interest will be accumulated, as you can see in the black on the non-aqueous medium, and eventually you separate out the impurities from the aqueous medium and the concentrate. Now, this is has a problem that you need to have use non-polar solvent. In fact, other methods also use solvent, but you use a lot of solvent in liquid extraction. Why? Why? Because the key point is liquid extraction is an equilibrium process. So meaning you never achieve complete extraction using such technique. So what you have, the result, there is less quantitative technique. So what you do in order to solve this one, you need to employ multiple extraction. To do that, you employ a lot of non-polar solvent, non-friendly solvent in your system. So in comparison to liquid extraction, solid phase extraction is nowadays commonly used. Why? Because it is 50 times more efficient than liquid extraction. And it yields quantitative result. As you can see in the previous slide, it is not quantitative. 100% you can't take out the analyte. The recovery is quite poor in liquid extraction. But here in solid phase extraction, you can use a better quantitative recovery. And it is also faster technique than liquid extraction, less solvent, and small time you spend using this for solid phase extraction. You can also automate the method. And the beauty of solid phase extraction is that it is non-equilibrium process, meaning you can quantitatively extract the analyte of interest using solid phase extraction. So what is the process in solid phase extraction? It is not like a filtration. Rather, you need to put your analyte into a sorbent. So on the sorbent, the sample, when it passes through the sorbent, the analyte of interest will be absorbed. Then once it is absorbed, in a small volume of absorbent. As a result, what happens? See, these are, look at this, are the absorbent will come later on the procedure, the operation part, but you will have steps you follow. And then the analyte will be concentrated and or separated from the sample, from a sample matrix. And then you apply a solvent, you elute the analyte of interest. Finally, you collect your analyte. Look at this demonstrative example. For example, you have 3 dyes, and these 3 dyes in black for the sample. Then when you apply different strength solvent, the dyes will be separated out. So 3 dyes, yellow, red, blue dyes can be separated out using solid phase extraction just by applying different strains of solvent in your system. Now, for what purpose you use it, solid phase extraction? How you use it, solid phase extraction? If we do not use solid phase extraction and you analyze using any instrument, what you have, for example, GC chromatography, what you have is a signal of small signal, and the background is quite difficult. We will come on that later on. But after you apply solid phase extraction, there is pre-concentration, enrichment of the analyte of interest. Why? From large volume of aqueous medium, you put it in a small volume of analyte of interest in solvent material. So it will be concentrated. So you can see it is a signal after pre-concentration, the signal is maximized. And to do that, what you do? What you do is, there are three ways you can to pre-concentrate your solution. You just pass large volume of samples through the small bed of solvent. This is one. The other one is just you use a small volume elution, and then you use a volatile substance. When it comes out from the solvent, after elution, the solvent can be easily evaporated so that it can be concentrated. The other technique we use for solid phase extraction is just for cleanup of your analyte. If you employ without any solid phase extraction, what you do is, you look at before cleanup, there are many signals in your chromatogram you observe. But when you employ solid phase extraction cleanup procedure, you see that the signal in the rate, only the analyte of interest signal is observed. So all interfering substances is removed. In this way, you can increase the sensitivity of your analyte of interest. So what type of solvent you use? There are commonly we use two types of solvent. One is silica solvent, where the silica is on the surface of the solvent. The other one is a polymer solvent. In the silica solvent, you can have, look at here, it is hydrocarbons, a polar medium, a non-polar medium, like C7, C80, C10, hydrocarbons can be used. But the problem with silica solvent is it is pH range is quite low. The range is between 2 to 7. If you go beyond this one, there will be hydrolysis, and there is the solvent, the active part, the C80, the C10, the C40 can be hydrolyzed and cleaved off. But if you use polymer solvent like this one, you will have polymer better than that of the silica. But why? You can, full range of pH can be used, and the capacity, loading capacity also better than that of silica. But these are the two commonly used solvent material in solid phase extraction. So what is the mechanism behind? What is the chemistry behind? The chemistry is you can have a normal phase where a normal phase is you have the solvent is, the solvent is polar. Polar substance means it has a dipole moment. Dipole moment means it has partial negative, partial positive charge in a bond. When you have such polar substance on the solvent, polar analyte can be interact. What interaction you have? There is a pi-pi interaction you have. This pi-pi interaction holds the analyte of interest, but if you have non-polar substance of analyte, there is no affinity toward this polar substance. We know that there is a fundamental aspect is like dissolve like. So non-polar substance will be like non-polar, polar substance likes polar substance. So what you have here is non-polar substance will be interact and least polar compounds elute first. So in that way you can say such technique we call it normal phase. The other technique is where you have a non-polar solvent like this, a non-polar solvent, solvent. Then non-polar substances will be interact by a van der Waals force. This van der Waals interaction fixes non-polar substance with your solvent, but polar substances easily elute first. So this one in the reverse phase, you can analyze non-polar substances. For normal phase, you can analyze polar substances. The other type of mechanism is just using ion exchange. The ion exchange, it could be cation exchange or it could be anion exchange. As you can see here, this is a cation exchange. So the solvent is anion. Your analyte should be a cation, so that there is an electrostatic interaction. This electrostatic interaction helps the analyte of interest. So weakly polar, ionic substances elute first. So you can separate out cation from the solvent material. The other one is if you have anion, you have the solvent is, as you can see, a cation, and your analyte would be anion. Again, the interaction is electrostatic interaction. So such interaction results weakly ionized compound elute first, then ionic substance, particularly anions, will be absorbed on the solvent you have. So how you do it in solid phase extraction? To do solid phase extraction, you need to have 4 steps. What is this? First, conditioning, then sample preparation, sample application or loading, then washing, and finally elution process. So in conditioning, what you do is just you activate the solvent substance. You activate. Sometimes the solvent contracts. Then when you add a solvent, you'll have right form of absorbent. So you activate during conditioning. Then you load your sample. during the loading, the analyte of interest and other interfering substance interact with your solvent material. Here, as you can see, the interfering substance will be elute out during washing. Interfering means other unwanted substances will be removed. Then, eventually, the analyte of interest, as you can see, elute last. So these are the common procedure you follow in solid phase extraction. Now, the extension of solid phase extraction is solid phase micro extraction. In solid phase micro extraction, what you have is you do not use solvent. Now, what we want is solvent-free, non-polar solvents are not appropriate for any system. So to decrease that, micro extraction techniques are employed. What you do in this technique, in solvent-free technique, what you do is the process is the same, sorption, desorption technique, but what you do is non-volatile substance, as you can see, non-volatile substance, you purge it with nitrogen, and then that non-volatile substance will be absorbed here. Then this absorbed substance, by passing another gas, you can use it for, and this is a equilibrium process. So what is the process in detail? The process in detail is, you see a fiber here. There is a fiber where your analyte of interest is absorbed. An equilibrium process, absorption process will be takes place. To demonstrate this one, typical example, I mean, in this technique, you will have a head space. The sample fiber is here. Your analyte, it could be a liquid sample, it could be a solid sample. And in this procedure, what you do is sampling, extraction, and pre-concentration simultaneously occur, just on the fiber. Then that fiber, you take it out, and then you put it into GC. Let me demonstrate one typical example for this solid phase micro extraction. The principle is the same as that of solid phase extraction, but the technique is quite simple here. Look at here, simple video. So these are the spring. You will see the samples are here. This is the holder. Look at. Now you put it, the fiber. You see the fiber is taken. Now the sample is placed, apple sample. Then this apple sample, you put it, the sample holder of a head space there. There is no contact between the sample and the head space. Then the volatile substance will be absorbed. Then finally, you inject it without any solvent. Then finally, you will get a result like this. And you can find this result, this food chemistry science. So what we have seen there is a solid phase extraction. Just by using that, you can analyze apple sample, the volatile sample, the volatile active part can be analyzed using solid phase micro extraction without using any solvent. The other type of extraction technique is supercritical fluid extraction. And this supercritical fluid extraction is one of sample preparation technique for solid sample. So far, what we have seen in solid phase in solid phase extraction, you can analyze liquid. In micro extraction, you can analyze just by using headspace, you can analyze volatile substance. And if you have a solid sample, what you do? What you do is supercritical fluid extraction. So this sample technique. What we use is supercritical fluid as an extracting solvent. So bioactive components from coffee, tea, hops, herbs, and spices can be analyzed. Later on, I will discuss on decaffeination of green coffee using supercritical fluid. To go to, maybe this one is appropriate in your field. From engineering, there is a phase diagram. From the phase diagram, you can see there is a solid, a liquid, and a gas. So substances can have this phase at different pressure and temperature. Now, what do you mean by supercritical fluid? Supercritical fluid is a fluid beyond a critical point. What is the critical point? When you reach at a certain critical point, critical temperature, the critical temperature is the highest temperature at which gas can be converted into a liquid, whereas critical pressure is the highest pressure at which liquid can be converted into a gas. So when you reach here in this region, it is not neither a liquid or a gas. It is simply a fluid. A fluid. Then this fluid has a behavior of between intermediate behavior, a liquid and a gas. It is neither a gas nor a liquid, but it is in between. Then it can diffuse through solid like a gas. This is an important point. It can diffuse through solid like a gas and dissolves material like a liquid. Because of this intermediate behavior, it behaves high diffusivity. This high diffusivity results, it can diffuse through gas, through solid like a gas, and because of high low viscosity, it can dissolve also material. Now, and at the critical point, you can tune also. Then the different system you have. So it is a better substitute of organic solvent. As you can see from our previous discussion also, we are looking for nowadays avoiding organic solvent, non-polar solvent. These are environmentally unfriendly solvent. So common supercritical fluid, you can use water as a supercritical. The problem is water is, it has high critical pressure and high critical temperature. As you can see, you need to apply 220 atmosphere or 374 Kelvin for water. But carbon dioxide is the most commonly used supercritical fluid for extraction. Why? Because it has a better capacity to dissolve analyte. And also, during expansion, the analyte of interest can be easily separated from your solvent carbon dioxide supercritical. Just increasing, and I mean, expansion results, decreasing increasing the pressure. You can, decreasing the pressure, you can decrease the solubility of analyte in carbon dioxide solvent. And carbon dioxide is, the advantage is very low PC and TC value, means critical pressure and critical temperature. If you look at the instrumentation of carbon dioxide, you'll have carbon dioxide gas. In fact, it is in liquid form in the tank, and 15 atmosphere. Then by applying heating pressure, you'll you'll have a system where you produce a supercritical fluid, and that supercritical fluid passes through your sample. Then the sample will pass through a valve. This valve decreases the pressure. When you decrease the pressure, the solubility of analyte of interest in carbon dioxide decreases and easily separate. So the carbon dioxide will return back, and the separated analyte of interest will be collected here. These are the simplest procedure you can follow. So the only thing you can do in supercritical fluid extraction is just appropriate instrumentation. Once you have this appropriate instrumentation, by decreasing the pressure, you can decrease the solubility between the analyte and the fluid, then easily separated carbon dioxide from the analyte of interest. So look at the decaffeination of coffee. I am interested in this decaffeination of coffee because Ethiopia is the largest producing coffee production. So what you do is you have a coffee bean. Then this coffee bean, you feed supercritical fluid. Then once you pass the supercritical through the coffee bean and decreasing the pressure, you decrease the solubility of analyte, caffeine. The caffeine is here. So that caffeine will be removed from the extracted. In fact, using the supercritical fluid, the caffeine will be extracted. Why it is extracted? Carbon dioxide is non-polar and caffeine is non-polar. So it dissolves, the supercritical dissolves the caffeine, and that caffeine, by decreasing the pressure, the solubility decreases. As the solubility decreases, the carbon dioxide, supercritical carbon dioxide, easily separate out from the caffeine. So you can decaffeinate your coffee. Decaffeination means separating out caffeine from coffee bean. So nowadays, people are looking for decaffeinated coffee. That's why you use such technique for coffee extraction. And by using this coffee extraction, the solvent is non-toxic, and pure caffeine can be extracted from your sample. Now, in summary, liquid samples can be easily extracted using solid phase extraction. Using solid phase extraction by operating solvent system, you absorb your analyte of interest, and then you wash it. By washing, you are avoiding interfering substances, then eventually you will get analyte of interest during dilution. The other technique is using solid phase micro extraction. Volatile substances can be extracted, as you demonstrated in the apple sample. Volatile sample can be analyzed. The other thing is bioactive substances can be extracted using supercritical fluid extraction. This is the whole. Thank you.
Thank you very much, Solomon-san, for your nice presentation. Talking about coffee, I noticed that our country is the 4th and the 5th largest coffee producer in the world.
Okay.
And however, Indonesia maybe most of the coffee is Robusta, and Ethiopia maybe most of the coffee is Arabica, right?
Yes.
Yeah. So, yes, but lately we also grown some Arabica coffee also here in Indonesia.
Okay.
But maybe your country is a large amount of Arabica.
Yes. In fact, the first, there is one region in Ethiopia, Kaffa, one state, like one in Japan, prefecture, like this one region, and that region, the main coffee extracted from that Kaffa.
I see. Okay, now we come to the question and answer session. For the audience, if you want to ask question, you could type your question in the chat box, or you can ask directly. Is there anyone who want to ask the question? So most of the participants is our students, but also there are general participants. Okay, please, anyone, if you want to ask question. Miss Dina?
Yes, Mr.
Okay.
Fatima, thank you very much for your thank you very much for the opportunity. Let me introduce myself. My name is Dina Wahyu. Dr. Solomon, I'm interested in decaffeinating of coffee. In decaffeinating of coffee, then what is specific component in extract production, in extract product or your coffee? What you get from the separation? Thank you.
Please unmute yourself, Dr. Solomon. Dr. Solomon, please unmute.
I thought my voice.
So
Okay.
the main component, there are many components in the coffee, but in decaffeination, what we are removing is caffeine. It is a compound, non-polar compound. So that compound will be extracted from other components.
So when we decaffeinating, we don't need to get to pre-treatment, or we get some what I said, milling, something like that, milling coffee.
What you do is a little bit absorption of steam treatment is needed.
Oh, maybe Ms. Dina want to ask, if you do decaffeination, how you prepare the sample? It is the bean, green bean, or
Green bean.
It is a green bean.
Green
bean. So we don't need to mill it, or we don't need to crush it.
You don't need any treatment. Just what you need is you need to hydrate a little bit before you extract.
So is that possible? Then we get the optimized extraction.
Optimization is during the critical pressure and temperature is important. That is the only thing you need to consider.
Oh, we get. Oh, I get it. So,
oh yeah, it is a really interesting topic about decaffeination of the coffee. I just know that we can extract the caffeine from the green, be a powder or liquid. No. Okay. So there are three kind of extraction method that has been explained by Dr. Solomon, including solid phase extraction and solid phase micro extraction, and also supercritical fluid extraction. So maybe I want to ask one thing. For you explained three kind of extraction method, then how could we decide which one is the best for our sample? For example, yes. For example, I'm working with cacao and also citrus. So how we can decide the method of extraction?
It is a good question. It depends on the sample you have. For example, if you have a liquid sample, you use simply solid phase extraction. It is easy. Now, if you wish to analyze volatile substance, you need to use head space. That is the micro extraction. It is an appropriate one. But supercritical fluid extraction is used particularly for solid sample only. You can't use it for gas. You can't use it for liquid sample. It is for solid sample use. So if you have cacao, the solid one, you can simply employ supercritical fluid extraction.
I see. By the way, how could in a solid phase extraction we use a liquid sample? How could it called solid phase extraction? I'm sorry. Could you unmute yourself?
Sorry, when you say solid phase extraction, what it says is solid phase only the sorbent.
Sorbent, yes.
Sorbent is solid. Instead of, you see, the traditional way of sample extraction is liquid extraction. You use liquid, and the liquid, you shake it using the separator fan. Now you change it from liquid to a solid sorbent.
I see.
So that the name comes from that.
Okay. Thank you. Is there any question from the audience? You could unmute yourself or raise hand first. Okay, Nehemia.
Okay.
Yes,
Am I
you can
audible?
ask directly.
All right. Good afternoon, Dr. Solomon. I would like to inquire regarding the solvent choice in conducting supercritical food extraction. Other than supercritical CO2, are there any solvents that you recommend to extract bioactive components that are not as volatile as water in SFE? Thank you.
Okay, about the selection
you.
of the solvent. Okay.
Thank you. It is a good question. This one, when you use a solid, for example, carbon dioxide, it is for non-polar substance. If you wish to analyze, your analyte of interest is non-polar substance, so carbon dioxide is very appropriate. But if you have non-polar substance, what you do is you need to add other solvent like methanol to the supercritical fluid carbon dioxide, so that non-polar substance can be extracted. If you have the technology and the money, water can be also used for polar substance. But it is quite expensive for water to have a pressure of that much in your instrument to pressurize that to get a supercritical fluid water. You need to have a large pressure. You need to apply. That's why commonly used is carbon dioxide, and you need to add modifier. The modifier, it could be methanol or ethanol can be used. Okay.
Thank you for your answer, Dr. Solomon. Dr. Dimas, can I ask another question?
Yes, please.
Okay. I'm aware that supercritical food extraction is rather expensive in terms of equipment, and it has high technical requirements such as very high pressure, such as lowering the pressure in order to reach supercritical state without using so much pressure. Is that possible? Probably using vacuum method or things like that to lower the cost of SFE.
As I have said earlier, why carbon dioxide is most commonly used. Again, your question is quite a good question. Why? Because carbon dioxide is, other supercritical fluid extraction is quite expensive. Carbon dioxide is relatively the temperature, for example, is 31 degrees centigrade to reach a supercritical fluid. And the pressure is quite low, relatively, 74. So far, as far as I know, the best solvent we know is carbon dioxide, apart from other advantage.
Thank you for your answer, Dr. Solomon.
Okay, thank you, Dr. Solomon, and also Nehemiah for the question. Actually, some of our lecturer here also conduct experiment on supercritical extraction of some bioproducts, and maybe some of the students also will conduct the same similar research. Maybe in the future we will invite you to be the examiner of some of our students, hopefully. Okay, is there any other question? Don't be shy.
In chat room, maybe, Dr. Dimas.
In chat room. Okay. There are two questions. First is from Desi Badar. Her name is Desi. and she is a high school student. In high school, she was taught that using the pectinase enzyme is a productive method to extract fluid from solid food. For example, apple juice. Her question is, which method can extract a more optimal fluid between extraction method that you explained? I'm sorry, between extraction methods like supercritical fluid or pectin enzyme. Comparison between supercritical extraction and pectin enzyme. Or maybe if I'm not really clear, you can read on the chat box, Dr. Solomon.
Can you repeat it?
Okay. She would, okay, I will just read. In her high school, she thought that using the pectinase enzyme is one of productive methods to extract fluid from solid food. And he would like to ask you the comparison between supercritical fluid extraction and the use of pectin enzyme for extraction.
Okay, for enzyme, I think the most appropriate one is not supercritical fluid extraction. In fact, the best way is solid phase micro extraction is the appropriate one. Why? There is affinity enzyme like a key lock system. So your sorbent, you can make it like a key lock affinity sorbent can be attached like antibody antigen or enzyme substrate interaction. So the sorbent can be made like a substrate, and the enzyme will interact with that substrate. You can separate out the enzyme. But using supercritical fluid extraction, I don't think so. I can't.
Okay. I hope it's enough to answer the question. Next is from Denisha. Okay, she wants to ask about what if the supercritical method fails to achieve the criteria or standards required for the usage in the extraction process.
If it fails, you need to try again.
Yes. So it could not be extracted. It could not extract anything. Yeah. So the instruments and the device, we need to be careful about the setup. Okay, is there any other question for Dr. Solomon? For any of you that want to ask directly? Okay, while waiting for any other audience who will ask, I want to ask also about the among three methods that you explained, which maybe many of them are used in laboratory, but which one could be scaled up for industry?
All of them.
All of them.
Yeah.
I see.
Yeah, maybe the micro extraction. Yeah, all of them. In fact, you can get in Germany, for example, there is using supercritical fluid. You can. They use a big company. They use supercritical fluid carbon dioxide for extraction of coffee, decaffeination. They do it. So all of them can be scaled up.
I see. Okay. In case of coffee, Dr. Solomon, Arabica has high caffeine, right? So, but sometimes actually people want caffeine. So, so why in some, for example, why they decaffeinate the Arabica?
This is a health problem. Some people are extremely sensitive for caffeine.
However, we could use the extracted caffeine for other purpose, is it?
I don't understand.
However, we could use caffeine, the extracted caffeine for other purpose, is it?
Yes, you can use it. We use decaffeination in order to have what is the purpose of caffeine, first of all? Just to excite you from some kind of drowsy feeling. So if you look at the biological thing, the caffeine interact with your nerve, and then you will be excited by preventing the natural way. So if you have, some people has extra sensitivity for caffeine. So they are advised to drink coffee without caffeine. So if you look at in Europe, nowadays, it is common to drink coffee without caffeine.
I see. Also, my experience, actually, I'm not a coffee drinker, but if I drink coffee, my heart beating so fast. However, when I was in Japan, I tried to drink coffee and I'm all right for some kind of coffee. I just wonder why. Maybe the caffeine low.
You know that I have never drink.
You never drink. So you drink tea?
Tea is best for my body. I don't know.
Yeah. Okay. Is there any other question from the audience? Please raise your hand. No more question? If no more question, okay. Okay.
Can I?
Yes, of course.
Thank you, Pak Dimas. Dr. Solomon, I'm still curious with the supercritical fluid extraction. So, can we know the detail of the supercritical extractor that was done in your research? Can we?
She is asking about are you doing extraction? How about the setup of your react? Because maybe she was doing also supercritical.
No, I wasn't. I wasn't. So can we know the detail, Dr. Solomon? Dr. Solomon is still mute.
Yeah.
So I have seen decaffeination in the organic stream here in our department. They use it using the carbon dioxide. I haven't tried it.
Is that a big a reactor or a middle one or small reactor or something like
It is
that?
a small reactor in the lab.
It's not about the glass chamber or something stainless steel or other materials that
It's based on stainless steel.
oh, in a sense. Because in the video, I was found is the glass chamber, isn't it?
Yeah, it is possible.
So what kind of the glass chamber for it?
Here I haven't seen that one, but
Oh,
it is stainless steel.
pardon?
I haven't seen that one
Oh,
in our class.
oh, you
Yes.
haven't seen. So how about in video that you in your video last time?
Video.
Yes,
Video.
the
Maybe
video.
the video was about
The video
solid
is
phase micro excellent.
Oh, micro
solid phase.
The video is about
solid phase micro. Okay, thank you, Dr. Salman. I still I still want to read again your presentation. Thank you, Dr. Salman.
Okay. Currently, we are here working on many kind of bioproducts, Solomon-san, and many kind of Indonesian bioproducts we are working on. Maybe I would like to know what is your current research and what kind of bioproducts are you working on in your laboratory?
What I am doing is not on the bioproduct, particularly for the time being. We are working on the absorption of heavy metals.
You're working on the absorption of
heavy metal absorption on biomaterials like lignin. You absorb it in lignin and then you remove it, this heavy metal.
So you're working with woods or grass?
No, we extract from the plant material, the lignin material. We will extract it, and that after extraction, we get lignin. Using lignin, we absorb the heavy metal, just wastewater. We pass the wastewater to the lignin, and then you remove the heavy metal from the
I see.
water. So before you release the water to the agriculture, you need to treat the water first.
So heavy metal removal. Okay. Thank you very much, Dr. Solomon, for your presentation and our discussion today. And today, International Guest Lecture is the last agenda of Bioprocess Engineering Week. We hope that we can continue this event next year, and I hope to see all of you next year also. Okay, Dr. Solomon, I hope that we could continue to collaborate. It's been a long time I'm not contacting you. And actually, I was waiting for you in Japan and you're not coming back again.
I'm tried for flying.
Yeah. Yeah, I hope I can visit you also in Ethiopia sometime. Okay, thank you very much. Thank you very much Thank you very much, Dr. Solomon, and all of the participants. That's all for today agenda. I will give it back to the MC. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Good evening.
Thank you very much, Dr. Salman and Dr. Dimas.
Thank you, Dr. Dimas, for moderating the session. And once again, I want to say thank you very much for Dr. Solomon for sharing your knowledge to all of us. I hope that the knowledge you gave to us today will be useful for all bioprocess engineering students here in the future. So, all right, let's go move on to the next agenda. After we had a long session, now it's time for ice breaking. So we will refresh what we have got from the session. So you can have some fun in this session. We will play quizzes. I will read the rules before we play the game. So the game will be held on quizzes. The link will be given in the chat room. And there will be 15 questions you need to answer. And participant must use the real name as username and no repetition of question in the game. And we will pick 3 winners from the game session. So each winner will get a special prize from us, of course. So yeah, you have to play seriously to get the prize, everyone. And all right. OC, maybe you can share the quizzes screen, and for all the participants, you can join the quizzes room by click the link in the chat room, and also enter the code. Or you can open in your phone, um, join myquiz.com and enter the code, the 6 code um, that show on the screen. Okay, so we have one participant already joined in. Maybe everyone can join also. I will wait for 2 until 3 minutes until all the participants join. Okay, so 6 people here, 7. We have like around 90 participants here, so maybe like we will wait until half of the participants join. Right. Okay, 10 people, 11. Oh, don't forget to use your real name, everyone, so we can know who played the game. So maybe it will be you who win the game. We can know who is playing. So the OC can contact the winner. Okay, 12 people here. Maybe we can still wait until 2:25. So maybe we can wait until 6 more minutes. Oh, for Dr. Solomon, maybe you can wait a little bit because we will have a photo session in the last uh, agenda. The quiz about actually the committee prepared it, so I don't really know the questions. Yeah, so you can just answer it, and I only can wish you a good luck. Yeah, for the game. Okay, so everyone is still 20 people. We still have like 90 people here. So please join the game. Okay, 25, 24. Why is this freezing? All right. Oh, okay. So the quiz is about today's topic. Yeah, so we will refresh what we got from the session. Okay. Okay, maybe we'll wait for 5 more minutes. Is that all right? 5 more minutes. I'll see. Okay, so 26. All right. Maybe everyone or participants can join. Okay. All right. 28. Does anybody want to join in the game? Okay. Okay. All right. Don't forget to use your real name. Once again, I want to remind you. So we can know who played the game and the winner. We can, have a validation of the winner, everyone. So please use your real name, like this one, Maria Felicitas. If you enter or we don't know who are you. So please enter with your real name, guys. Maybe, yeah, we can still have more time if you want to change your username. Remember, we will give you a special prize. Okay, so for 3 people, you will get e-money from us. Okay. All right. We'll wait for 3 more minutes. And we can start at 2:25 p.m. All right. Does anybody want to join in again to the game? Okay, maybe while waiting, I wanna ask how about the session today? Everyone, maybe you can say your thought in the chat room. Maybe you feel like, oh, it's very amazing, or you feel very happy to get the knowledge or anything. Okay. You all must be excited because we will give you a gift in the session. All right. So, okay. Is there anyone want to join in again? Okay, this guy to join. Here we have Inda, 36 people here in the room. All right, 1 more minutes, 1 more minutes. Don't lose your opportunities to get the prize, everyone. So please join in before 25 to 25 p.m. Yeah, we still have 1 more minute. Okay, 27. Oh, don't forget to use your real name, okay, Ka? Okay, 38 people. Okay, is there anyone want to join again before we start the game? Okay. All right. I think it's enough. So maybe for those, you can start the game in 3, 2, 1. Let's go. Good luck, everyone. All right. We have Inda. Oh, Danisha in the first line. Okay.
you.